Swayam Prabha. Digital India. Educated India.
Shubham or Darshil, can you just? Okay, yeah, I guess everyone has it. Okay, so you can do two things. One is you can download the exercise from my GitHub, so I will just share the link, or you can open it in Google Colab. So I will just say, so everyone just go to this particular link. So here there is ACM Geometric Deep Learning repository. So those who are using GitHub can just clone this repository, and if download it as a zip file. Let me know whichever once you have done, so that we can move ahead. I guess most of you must have downloaded it. So if you have a Google account, just go to Google Colab. So there would be welcome to collaborate link. Log in with your ID. Then in the GitHub section, so if you want to directly access the notebook on the Google Colab, just write my name and just search for the notebooks basically. So these are the same GitHub repository notebooks that I just show in on my GitHub repo. You can download it and use it in Jupyter Notebook as well. You in Anaconda Python. So it is up to you how you want to try and debug the session. So just the third one would not work in Anaconda Python because it's difficult to install PyTorch geometric in Anaconda. So it's better if we try it on Google Colab. So let me just briefly give you ideas. So there are 3 lab sessions basically. First is just introducing the PyTorch. So just basic operation on PyTorch and how it is done. So there are some to-do sections to complete from your side. So if you don't have time, there is a solution available in the solution folder with the same name. But I would say just try for some time, and if not able to get it, then refer the solution. Uh, the second is basically where we have implemented graph convolution layer and graph attention layer. So those are the basically 2 architectures that we tried to discuss in the presentation. So there is no to-do section in this particular notebook. Everything is implemented. You just need to run and see there is some theory written and there is the implementation. So you can just run an experiment with yourself. The third is where we use the Cora dataset that is available in PyTorch geometric, and that is a citation network data set. So that data set, we will use it on our graph convolution layers. So in this exercise, we have implemented our own graph convolution layer, So the equation that we mentioned in the presentation, that is actually been implemented, and the layer has been implemented. And we will also use the predefined layer in the PyTorch geometric that is available, that is GraphCon. So I will also, based on both these two layers, we will train our model and just evaluate the model for accuracy. And we will plot the accuracy graph for both of this implementation, basically. So this is the third lab. So again, in the third lab, as PyTorch geometric is used, it would not be running well in Anaconda Python because PyTorch is difficult to install. PyTorch geometric is difficult to install on Anaconda. So there is another .py file, that is Python file, which you can directly run using your Python interpreter, where you have installed the PyTorch geometric library using pip install. So for those who haven't installed PyTorch geometric, just in the Google, go to PyTorch geometric. There would be read the docs documentation, and in that, go to installation section. So for this, there is this pip commands that are available. So you need to run this pip commands to install in your local Python environment, right? So coming back to first, so is everyone with me, or you are still struggling with the download and login of the Google Colab? Okay. Okay, so Google Colab is again, you can use this freely, but partially freely, you can say. For GPUs, it is not supported well enough in the free thing. So this is just like a Jupyter notebook environment on the Anaconda Python you use. So there is a text markdown, and the code is also, you can write code and run at the same time. So for this, I also mentioned the PyTorch tutorials available on the website. So you can, whenever later on, if you get time, you can just refer these tutorials. Those are very good tutorials available. So first, this is the code where we import some standard libraries that would be required. Again, Seaborn is a plotting library. Uh, don't worry, in Colab, you can just do this play thing. So it will run this particular cell. So just to run anyway. So it will allocate one of the system on the cloud, and once connected, it will run your code in that environment. So it's initializing now. Yes, it's connected. So if there are any errors during this run, you will get in the below console, below output at the same time. So there are some few sections that you need to complete. So you can refer to the tutorials or documentation. It's easy enough and nothing uh, you can say complex in particular, this particular exercise. So first you will import torch. So that is PyTorch is basically the library name is torch. So import torch, and you can just check the version using torch __ version. So if you run this, it should be 1.9, I guess. Yeah. So PyTorch comes with CUDA installation. You can say CUDA libraries also. So CUDA is a library required for running your code on GPUs. So running this machine learning codes on GPU is very fast compared to CPU, and GPUs are specialized in such type of matrix multiplication and such stuff. So, and CUDA is required driver, you can say, for running your code on GPU. And this represents the CUDA version that is available on this particular cloud system, 10.2. So whenever you install PyTorch geometry, this is again a very important thing that you need to verify your CUDA version and the Torch version, and then you need to install PyTorch geometry. Okay, so going to next, much random things we do in the weights and biases of the neural networks. So if this manual is not set, then what happens is every time when you run the uh, program for debugging, you will get different outputs basically, because the weights are randomly initialized, and so at some time probably an error occurred, but it's not happening every time. Then that makes difficult while debugging. So be sure to make, or you can say set this manual state. You can set any value. I have just, for example, set as 7. So what happens is whenever next time you run this particular program, the weights would be randomly initialized, but in some sequence that is constant when you have this seed value as same. So make sure you do this whenever running this torch examples. Okay, so I guess if you have used TensorFlow, Keras, or PyTorch before, you already know what are tensors. So, and even if you don't have worked with, tensors are in general n-dimensional vectors, you can say, in a simple sense. And they work very well with the GPU. So even the single numbers can be considered as 1D tensor, and a matrix can be considered as a 2D tensor. So matrix, there are two values, rows and columns. So those are considered as 2D vector tensors, basically. And if you go one more level up, the 3D tensor, then there is a third dimension that is there. Uh, and you can consider it as a depth for the third dimension. But you can go beyond that, fourth dimension, fifth dimension. So we don't have got any names for that. But tensors are basically n-dimensional vectors. You can consider that. So how would you initialize tensors in PyTorch? So there are multiple ways. So first is torch.tensor, and you provide the size. These are not vector values. Here, these are the size of the tensor you want. So this is a three-dimensional tensor, you can say. Two is you can, just for sake of example, consider 2 is the length, 3 is the width, and 4 is the height, something like that. But you can go up till any dimension basically. So if you see, there are basically two rows. Consider these as a rows, one row and two row. And in that, there are four values in one row, and we have three such rows, correct? So this is a tensor of size 2, 3, 4. Now you can experiment with it using just two values like 2 by 2 and just run it. So you will get a matrix, or you can say 2 by 2, two rows and two columns basically. And currently these values are random because we have just assigned a memory to tensor and we have not assigned any values. So for predefining the values, there are functions like torch.zeros, torch.ones. So in that case, all this would be 0, all this would be 1. Similarly, there is a random. So these are the functions you can try and experiment with yourself. I will just give you time after I explain the whole tutorial so that you can just try. Or else you have got the solution file as well. Run that and see the output. So you can construct a tensor from a NumPy array. So NumPy is again the basic, you can say, numerical library for Python. and that is there. So now there are these to do sections that are available that you need to fill in the three dots. So remove these three dots and then add your code here. So for this, you need to create a tensor with these particular values. So it is pretty straightforward enough. You can try it out. The second to do is you want random values between 0 and 1, and the shape should be this. So again, this is straightforward enough. So once this is done, you can experiment with the shape of the tensor. So once you create this, just try and print the x dot shape. This returns the shape of that particular tensor. So, and the size, again, the size would return the size of that particular dimension, or you can say the entire tensor. So you can experiment with this. The solution is also available, and you can first try with yourself, because these are basic operations and nothing in complicated type. So operations side of view, so basically in this example, we have shown to add two numbers, or you can say two tensors. We forget about numbers, we talk about tensors. So this will initialize a random tensor with random values of size 2 cross 3. And same thing, this would initialize random values of size 2 cross 3. So two columns and three rows or similar thing. And you need to add it. So this is again straightforward. Once you add it, you can print the value of by tensor. Also, you can print x1 and x2 tensor. It's up to you. Now there is another operation where you want to do in-place addition. So for in-place addition, there is an function with an underscore. So for x2 dot add underscore, if you will do, then the x2 values would be updated with the sum of x1 and x2. So this is basically in-place operation that takes place. Okay. Now this section of code is basically we want to change the shape of a tensor. So in NumPy, we basically do dot reshape thing. The same thing can be done using the view command, dot view. So you can experiment with changing the dimensions of the tensors here. To create an first 1D tensor, then just rearrange or reshape it to a 2 cross 3 tensor, something like that. So this will just make your concepts clear regarding how the tensor dot view works. There is another function dot permute, which basically swaps the rows and columns dimension. So yeah, you can just try with the examples so that it gets a little bit clear. Now the main thing, so entire neural networks and all works on this matrix multiplications. So for that, there are majorly this 3 to 4 functions that are available. Dot matmul, dot mm, dot bmm. So the difference between bmm and mm is just that this is used for batch processing. Consider if you are multiplying n cross m with m cross p, but you are working on a batch, or you can say mini batch size. So if someone, those who have done machine learning course must have known the batch, what is batch, and batch is basically a group of data that is fed at the same time for the algorithm to train. So at that point of time, you can provide this batch size and use the torch.bmm. And so this is again an esum, so it's not required much for our, but it's mentioned here. So this is an example of multiplication that you need to implement. So as you can see, the above sample, so here you will get a 1D tensor of 6 length, but then you have rearranged or reshaped it to a 2 cross 3 tensor. So the same task is given above here. So you can experiment it here. And just you need to multiply the two metrics. So one thing to note that we all already know that the number of columns and rows should be matching of the two matrices for multiplication. Now this indexing thing, so this indexing thing is just like a slicing operator in Python, so where you slice the list to get only a particular values from that particular list. So you need to do this particular task here using the slicing operation that just get the second column or just get the first row and something like this. So these are the tasks that are assigned. Now the computation, or you can say dynamic computation graph and backpropagation. So in neural networks, this backpropagation, as I already mentioned, we update the weights of the nodes basically based on the loss that we have calculated. So this is basically that thing, and those are called as parameters, or we can call it at weights. So these are basically the values that are obtained after training a model. So we use stochastic gradient descent or something other optimization algorithm for that. But the main thing is the derivative term. So we basically make use of derivations. So here there is a short brief idea about what is and why it is required. But in TensorFlow, to calculate a derivative, or you can say allow TensorFlow to calculate the derivative, uh, you require to set this particular requires grad variable to true. So when you print this out, you will probably get false for now. But if you set it explicitly using this, then whenever you do a back propagation, the derivative of that particular tensor will be calculated. Okay, so to understand the computation graph in PyTorch, this is a short example. You can do this, you can verify this, you can by hand, you can derivate this particular thing and calculate the value with the input 0, 1, 2. And same thing can be done for this. So you need to implement this particular thing in steps basically. And what are the steps? So basically you can see x plus 4. So this is x plus 4 is the value of a. So here you have to calculate x plus 4. Then b is what? It's the square. So this square is 2. So you have to calculate the value of b here. And then so this is basically a computation graph that follows in PyTorch in the backend. So whenever you calculate, or you can say do a back propagation for the value y, it that propagates into this particular thing. So this all needs to be derivated. So you must have remembered the chain rule in 11th standard. You must have learned about in the maths. So using the chain rule, yeah, so it is mentioned here. So if you want to derivate dy with respect to xi, so xi is our input vector, we basically do a chain rule of derivation for all the individual subcomponents. And you can verify this manually. So this is the value that we get after doing manually also, and after running this, implementing and running this sample. Okay, so GPU support. So as already mentioned, PyTorch has got GPU support inbuilt. And why GPU is required, or what is the difference between CPU and GPU? So yeah, it's central processing and graphic processing unit. So CPU has several cores, but GPU has a lot more cores, you can say. Latency for the CPU is low, but the output, or you can say throughput of the GPU is high. So whenever you want to process something in parallel, so in our case, the metric multiplication that we want to perform works in parallel. So that is why GPU are most preferred while training a machine learning model. It can be done on CPU, but slightly more time is required for training on that. And yes, you can process the things in parallel, so thousands of operations can be done at a time on GPU. So, hello. Okay. So to check if you have got support of the GPU or not, you can just check torch CUDA is available. So if that is available, then it will show you, and you can use that as a device to send the data to that. So as you can see here, so if device CUDA, matlab agar if CUDA is available, then go for device as CUDA, else use CPU. So once you do this, and when you print the device, it will be printed whichever is available. So if you are using CPU, it will be printed CPU. And you need to push the data to this device in TensorFlow. For example, if it's a GPU or CPU, whatever it is. So if you have this tensor and you want to perform some operation, you need to do dot send dot to and the device name. So with this, you will able to send the data on that. So CUDA 0 is basically GPU, and CPU will be printed for if you are using CPU. Now, this is just a program, or you can say command, to just test the timings taken for CPU and GPU processing. A thing to note that for the first time when you run with GPU, it takes some time to initialize. But once that is done, it is pretty fast and loaded compared to CPU. So you can try and run and see the difference in timing. You can increase the operations multiple times to get the better picture of that. So same thing as we set the manual set for randomness for CPU, you can just set it for CUDA or GPU as well. So this is a simple example of XOR data set. So in this, if there are two inputs, basically, we had seen this type of example in the uh, TensorFlow playground in the morning today. So the two inputs, if either of them, you can say it's basically an XOR bridge. So for this, we have implemented a model. So in TensorFlow, to create a model, you need to implement the NN module. So torch.nn as so this would basically alias the library as NN, and this is the function. So nn.module, we need to implement it. So this works basically in a more object-oriented way, and TensorFlow 2 is now you can say more similar to what PyTorch is basically. So this init is just the constructor of this particular class, and we need to derive it from nn.module. And you need to construct the layers, or you can say initialize the parameters in the constructors, and in the forward function, you need to implement the actual calculation that you need to perform. So for this, classifier for XOR, so here you need to implement two linear projection layers. So once that is done, you will have to activate so nonlinear activation function. So you can use any nn.10h is also there, sigmoid is there, ReLU is there. You can use any. And in this forward section, you need to implement the classifier, basically means use this layer, stack this layer as per the requirement, and get the value or the result here. So this is implemented in the solution file, but try for yourself and then you can go and see the solution. Okay, so now once that is constructed, so here we are actually trying to test, or you can say run this particular simplifier that we will implement, and we will print the model. So this will basically print the 3 layers or 2 layers that we will implement with the parameter name. So you can again print the name and parameter using this named parameters function. So this will basically return all the parameters in your model. So for this is very simple and 2-layer model. But for more complicated thing, you can then see how many layers are stacked and what is the input dimension of layer and what is the output dimension of layer. Again, this is the data means PyTorch has got this data module which helps us to work with data. For example, data loader is there, data set is there. Yeah, data set is there, data loader is there. So this helps us to, so whenever we are creating, or you can say, uh, implementing a problem, so we will require some data set. So for that data set, we want to create our own data set, and for that, this data set class is there. So you need to derive this dataset class, and then you need to main two functions that you need to implement is length function and get item function. So these are basically just iterator for our dataset, and this is just internal function to generate all the data. So in some cases you will generate at this place, or in some cases you will be loading the data from some files, the data here. Set, this is data.dataset is the class which you need to derive from, and for that class you need to implement two functions. One is the length function and one is the get item function. Yeah, okay. So once that data set is constructed, we will actually use that data set. So here we created a data set, and this is just printing how the data looks basically. This is just a function to visualize that data set, nothing more. So it's okay. So the data loader class. So this again helps in loading the data that we have created for the actual training application, you can say. And once you load the data set, this is the batch size that I was mentioning earlier. And so uh, when you have got some data or sequence of data, it is good idea to always shuffle your data for the training, because that makes your code more uh, generic enough, or you can say it would better generalize the training instead of just sequentially passing all the data. So for that, you just need to pass shuffle to true, and the data loader will handle everything from its side. And whenever you require next set of data, you just use next item. So you will get the data inputs and its label. And this will basically call the get item that we have implemented. Again, so all the problems are of optimization. And so even in this case, we require optimization. You can use stochastic gradient descent. You can use Adam optimization. You can use this loss function, binary cross entropy. So we need to reduce this loss. So for that, optimization is required. And so you can just call this BC with logits loss. So there are multiple types of loss functions also available. So you need to refer the documentation and see which is better for your particular application. For example, here already BC loss and BC with logits loss is mentioned here. And this is stochastic gradient descent. You can use optim.sgd. You can use optim.adam to use Adam optimization. Uh, LR is the learning rate that you need to provide. You can provide variable or you can provide the fixed thing, and you need to pass the model parameters. So these are the weights basically that you need to optimize. Uh, Weights, so that these are the outputs of the training that you will get basically. For the training the data set, again we need to move the data to the device which is there, so CPU or GPU, whichever it is, and also we need to push the model to that device before that. So once that is done, we'll call model.train, and so these are the number of epochs these are being printed, but these are the to-do tasks that you will have to do. So you will have to move the data to the device that is there, then run the model for prediction and calculate the loss. Once that is done, you need to back propagate it. So you need to do backward and then propagate that loss with the above parameters that are there. And once that is done, you need to update it. So you can just directly run this train method once this is implemented. So it will train that. So saving the model. So once you have got the model trained, so it's not good that every time you will train your model before using it. So what you will do is you will train your model and save that model so that you can use it multiple times. So for that, Torch has got a .save method. So the state takes is basically all the trainable parameters that have been trained, the weights that we were mentioning about, that all would be dumped to a file. And once you load that particular file using torch.load, you can load the structure of the model, or you can just create the structure of the model and just load this particular dictionary to that new model. So now this new model has already got pre-trained weights. So now you can use directly this model for prediction or inference basically. You can get more examples in PyTorch documentation as well. And this is evaluation. So whenever we train our model, at the time we also evaluate that what is the validation loss during the training, or what is the accuracy of our model. So this is just the general formula of true positive, true negative thing, and that is being calculated on the data set. And this is the eval method. It is pretty similar to the training method, uh, just that you need to calculate these values here, nothing else, so that you can get the accuracy of the current training in progress. And this is just a visualization of boundaries, so you can just try it out in your example. And yeah, so this is the first exercise, and you need to complete the to-do list that are mentioned here. So for running this, as already mentioned, so whenever you go to this code block and just to play button, it will run your code, and you can edit it at the time and then run again. So you can just try with this, play with this, and I guess within 5 to 10 minutes we can go with the next exercise if required. Or else if you feel, then I will just run the solution file here, and we can see the output if required.